Hi guys, for today's lesson we're going to be dealing with distance time graphs. So first up, what do I mean by a distance time graph? So it's a graph of straight line segments or kind of sections, which are straight lines, which display the distance to and from a particular position over time. So that probably doesn't make too much sense, but hopefully this example will clear it up. So the idea is that you've got distance along your y-axis, so this measures how far you've sort of traveled, and on the x-axis you've got time, so that goes up in time. So like we've got 1 hour, 2 hour, 3 hour, 4 hour, etc. So as time goes by, we go further and further along this axis. So the idea is this black line here that we see, it's made up of all these like sort of straight line sections, and they kind of represent a journey. So first up, this distance is away from a particular position. So like for example, this position down here in this situation is like, we consider that to be like home, like the starting position, and then this length up here is like someone traveling away from home. They travel, if we have a look at those numbers, they travel 8 kilometers away from home, and that takes them 1 hour to get there. So that point is saying that they traveled 8 kilometers in 1 hour, which is pretty easy if you say doing that on a bike or if you're doing that in a car, etc. And then for the next, if you look at this line here, for the next 3 hours from so we're going from 1 to 2 to 3 to 4, so that's 1, 2, 3 hours. They literally stayed at this 8 kilometer distance away. So along this place here, they kind of stayed put. Then they traveled a little bit further here. They went 10 kilometers away from home, and then they stayed put there for a little bit. So these sorts of flat sections here, like here and here, that is saying that they remain stationary. So like this part here is remaining stationary for an hour because it's from here to here, and that's the sort of the duration of an hour. An hour is like 2 squares in this graph. And then when it comes back down, when these lines are going back this way, it's kind of like they're coming back towards home. So he goes pretty much 10 kilometers away from home. He gets all the way up to here, and then he travels 10 kilometers back towards this position. So as he's coming closer and closer, his distance away from home is getting lower and lower. You're coming closer and closer, if that makes sense. And eventually it comes back to 0, so it's like it returned back to the starting position after 10 hours. As you can see here, it took 10 hours to get back to the start. So note, distance is always on the vertical axis and time is always on the horizontal axis. Make sure you put time down here and distance on the side here. So some rules to remember. So you need to remember the following trends of different distance time graphs. You need to remember that these flat sections mean that they're stationary, they're not moving, really important. And you also need to remember that steep lines, like for example that line right here, it's very steep, that suggests that you're going at a high speed, you're going very fast. Whereas these sorts of flatter sort of lines, that suggests that you're going slower. So that would be very fast there, that looks relatively fast, that looks relatively slow, and that's a lot steeper, that looks quite fast. So let's do an example question. So consider the following distance time graph that describes Sally's journey to and from work. So you can see here in this section, she's going away from home. She's going probably to work. Looks like she's staying put for a while here, so that's probably when she's at work. And then she looks like she's traveling back towards home in this section. But it looks like she's had some sort of break somewhere. Okay, so how long does Sally take to get ready for work? So that's going to be before she leaves. So you can see here in this sort of situation where she's staying at home, that's when she's probably getting ready for work. So she's getting ready for work for this whole time period, and that's going to be from 0 all the way to 1. So that's going to be 1 hour right there. So she's got 1 hour of getting ready. So if I'll just highlight that part there. So that length there is going to take her 1 hour. Okay, next up, So Sally rides her bike to work. How fast does she travel? So she rides her bike to work. This is when she's going to work, this highlighted line here. We've got to think, how fast does she go? Well, speed is equal to distance over time using the DST triangle. Now, on this line, she travels 9 kilometres. It gets all the way up to the 9 kilometre mark. So our distance is 9 kilometres. And this literally takes her an hour. She goes from 1 hour to the 2 hour mark in this time. If we follow that down, that point goes straight down to the 2 hour mark. So that's going to literally take her 1 hour to travel those 9 kilometres. 9 divided by 1 equals 9 kilometres per hour, which is the units for speed here, because kilometres per hour. Okay, so on Sally's bike ride home, she suddenly breaks her bike chain and is forced to push her bike home. At what speed does she push her bike? So if we look here, this is her journey back home. You can see here she starts off going very fast. She's probably on her bike, and then suddenly she has a break for how long? So that line there looks from about halfway to 7. So that kind of looks like maybe half an hour. It's not quite a full hour because it's not long enough. And then she suddenly has to go a lot slower. It's a lot less steep. So we got to figure out at what speed does she push her bike. So she's pushing her bike in this slower section right here. So we got to think speed is still, we got to figure out how fast she's doing it. So distance over time, that's what's equal to speed. So for this section here, this slower section, she goes from, if we look across, that's 5 kilometres all the way to 0. So she's travelled 5 kilometres for that section, and it's taken her from this mark here all the way over to 9. So from 7 hours to 9 hours, that's 2 hours. So 5 kilometres over 2 hours, and that equals 2.5 kilometres per hour. That's how fast she's pushing the bike. How far does Sally travel throughout the day? So, well, the way to do this sort of one is to think to yourself, well, she travelled to work. That was roughly 9 kilometres. So she travelled 9 kilometres there, and then she travelled back the same distance. She's travelled another 9 kilometres back home. So we're going to be doing 9 kilometres plus another 9 kilometres for the to and from work journeys. And that equals a total of 18 kilometres that she travelled throughout the day. Okay, I hope this helps with the questions. Good luck.